Assalamu alaikum wa rahmatullahi wa barakatuh. Dear students, in our previous session, we have worked on the concept of correlation, and also you have learned how to compute and find out the correlation using some statistical methods and formula, dear students. In this session, inshallah, I learned regression analysis. Okay, the difference between regression and correlation is very much simple. In correlation, you have learned that it was just simply for the relationship, just to check how two variables are related, whether they are positively related or negatively related, and whether the relationship is strong or weak. So the range is positive one and negative one, and if it is getting closer to zero, it means there is no correlation. But dear students, in regression analysis, we are just checking or measuring the relationship between two variables in some have different contexts. Here we are just measuring whether one variable which is independent variable is affecting the other variable which is dependent variable, dear students. So what is the relationship between independent and dependent variables? So dear students, in regression analysis, we are interested in causation, which is just we try to check whether one is affecting another, and what is the magnitude if one variable is increasing, how many units of other is increasing, how the y are dependent variable is just depending on the independent variable, your students. So first I'm just giving you the concept. What is the definition? Regression analysis studies how one variable which is dependent variable changes in response to another variable which is independent variable, your students. Okay, regression aims to estimate or predict the average value of a dependent variable for given values of one or more explanatory variables, dear students. So independent variable is also called explanatory variable. Okay, for example, dear students, we have an example. We have two variables. One is x and y. X is independent variable and y is dependent variable. Assume x is the advertising budget and y is the sale. So we are just measuring how the sale, so how the advertising budget is affecting the sale, dear students. So for this purpose, just collect the data on both variable x and y. Okay, for this relationship, we have the function of regression, right? Simply, we have y, and that is equal to, we have beta naught, right? And plus we have beta 1 x, right? And then we have plus u, which is error term. If you remember, this is something we have explained about regression. But dear students, this is the population regression function, okay? And in this function, dear students, this portion, right, this one, this is also just indicated, or you can show it like this. You can say the expected value of, okay, we just expected value of y given x, simply you can say it like this. So the expected value of y given x, right, this equal to beta naught, simply beta naught, okay, plus beta 1, right, this is beta 1, dear students, and then we, okay, we have x, simply, okay. Okay, dear students, now this is the population regression function, right, which can help us find out the relationship between the two variables. Since we have sample data and this is not the whole population, then we are using the sample regression function for this relationship, dear student, and that is equal to, we have y hat, okay, you can say this is y hat, and this is equal to beta 1 beta, okay, this is beta naught hat, this is beta naught hat, simply, and then we have positive beta 1 hat, okay, beta 1 hat, simply, and then we have x. Okay, dear students, so this function, simply this is just used to predict the regression line. So you can say this y is estimating this expected value of y given x, right? I just explained this, okay, and this beta naught head is just predicting the beta naught, right? And beta 1 head is just predicting the beta 1. So beta naught, this is the population parameter, dear students, and beta 1 is also population parameters. And these are just sample statistics, or you can say the point estimates of the beta naught. And beta 1 head, this is just estimating the beta 1. So these are just based on the sample statistic. In these are, dear students, the population parameters. So this y hat, this is just predicting the expected value of y given. It's mean the average value of y given x. This is also called population conditional mean of y, students. Okay, in this equation, the first thing you should learn is the beta naught. What is beta naught simply, right? So you can say the beta naught, which is beta naught. This is, we call it intercept, dear students. Okay, in beta 1, this is the slope, or you can say coefficient coefficient, right? And also it's called slope, dear student. Okay, so what is meant by beta naught? Beta naught means if we have a regression line. Okay, first I'm just giving you the regression line for these two variables. Just select these variables and click on the insert, and then click here on the scatter plot, and here we have the regression function. Simply uh, click on this and then on plus, and we have a trend line, and then just double click on this line, and here just display the regression function, which is display equation on chart. Okay, click on this, we have equation. This is our equation. Okay, this is the equation just we want to know about. Okay, just make it a little bigger. Okay, dear students, so here the based on this data, the beta naught or beta naught height, this is also pronounced like beta and also beta, and the beta is just American pronunciations and beta is British. Okay, so the beta naught height, this is 39, dear students, and this 5, this is beta 1. So what is meant by the beta naught? It means if x is taking the value of 0, then the beta naught is equal to 39. Okay, it equals to 39, dear students. What does it mean? It means if the x is 0 like this. Okay, let me just show you in this graph. If x is 0, right, if you just make the x 0, right, then the y-intercept is 39, and that is just coming here. Okay, in this point, this line. Okay, so this is the point of uh, beta naught or intercept. It's meaning when the x is 0, so the beta naught is here. According to this regression, you say if the advertising budget is 0, still we have the sale of 39,000. And if you increase the advertising budget by 1 unit, then your sale will increase by 5 unit, students. Okay, this is the concept of the regression function, but this regression function is based on the sample statistic, dear students. Why? Because we have taken the sample there. That's why this y hat is the population conditional mean of y. This is estimating the population conditional mean of y, or the expected value of y given x, and this beta naught head is estimating the beta naught, which is population counterpart of beta naught head, and this is beta 1 is the population counterpart of beta 1 head, dear students. Okay, the question here is, if you compute this function, estimate this function, so you need two information, just beta naught and beta 1, and in Excel just give us both of them, and beta 1 is 5 and beta naught is 39, dear students. So how you can do it simply or manually? So for beta naught and beta 1, dear students, we are using two equations, right? And that is simply these two equations we are using. Beta, this is for beta 1 and this is for beta naught. But before this, dear students, simply what is the expected value of y given x? It means whenever we are predicting the y hat, this y hat is actually predicting the population conditional mean of y. So for example, this 2, this is x. When the x is 2, then you can say the y is 60, right? In this graph the y is 50, sorry, and when x is 4, then the y is, you can say the y is 60. So these are the actual values, but this line is just giving you the y head, and each point on the y head is estimated is the y bar, as you can say y head, right? This is an estimated value. So the line is just predicting the central value. For example, if you have more values, okay, just I'm explaining it. If you have the actual value, this is actual value and this is the second actual value, and here we have another actual value, right? More actual values, right? Then dear students, this value, which is this is the y head, this is just estimating all the value. This is the average of all the values. So you can say if there are many more values, right, then this is the average. Simply this is the average. The line is just giving you the average value. Okay, I'm just showing, I have a better example here in the graph. Okay, for example, dear students, we have, this is an example. If you remember, I have given an example of the height of the fathers and the son. Okay, for example, if the height of the father is 60, right? So in 60 there are many individuals with different heights, so the son's heights can be different and they can take different values. So the regression line is just predicting the central value. You can say y, the expected value of y given x, it's mean here we have different values of y. Okay, so these are different values of y's we have, right? These are different values of y given x. This is given x. Okay, for this x we have different value. So regression line is just finding out this central value. You can say the expected value of y, right? When we are talking about expected value, dear students, mean the average value. So the expected value of y given x, sorry, this is x, expected value of y given x. Okay, so look here, the expected value of y given x. So we have many variables, many values of y, but given x, this value is returned by this predicted line or regression line. So for this 65, this given x, we have many y's, but this is the expected value of y given x. So for this x, we have, this is the central or the expected value of y given x. So dear student, when you are talking about the population conditional mean, so you can say the y is the population mean, and when we are talking about conditional mean, it's mean given x, that is a condition. So the expected value or the average value of y given x is just computed by this line. This line is just giving you this prediction, dear students. Okay, hopefully this concept is clear. Okay, now, okay, this was just the basic idea and the concept of regression. Now, how you can compute the beta 1 and beta naught, dear students, using Excel. Okay. Okay, before Excel, how to do it manually. If you just try to find out the beta naught and beta head using the manual function, how to do it. Okay, look, dear students. Simply, in this data, look into this equation or this function. Here we need x minus x bar. So first you should find out the average value, right? The average value, which is the x bar value. So first find out the average. This is the x bar. And also we have y bar. This is y bar. And next is x minus x bar. So x minus x bar. So equal sign, from each x value you should subtract the x bar value, right? Simply, and just drag it down. This is the x bar, and then you need y minus y bar, and from each value of y, just subtract the central value or the y bar. Simply, just use and press enter and drag it down. Okay, this is y minus y bar, and then you just need the product of both of them. So x minus x bar, and it should be multiplied to y minus y bar. This is a product of both. Simply, and equal sign, just multiply both of these values. Okay, we found out this denominator, okay, and just drag it down here, and then you should take the summation. So we found out the denominator, which is 200. X minus x bar, y minus x bar, the product should be just sum. This is the product, and this is its summation, okay? Now the next is summation x minus x bar square. So you should take x minus x bar, and this should be square. So equal sign, and just type power, and this is x minus x bar, and raised to the power 2. And just press enter, and just drag it down. So this is the denominator, and you should sum it. Why? Because here we have the summation. Now, dear students, for beta 1, which is the coefficient, beta 1, simply we have the function. The numerator, which is the 200 value in our example, should be divided by the denominator, which is 40 simply. So that is 5. We found the 5. And what is the beta naught? So for the beta naught, dear students, simply just use this function. So we have y bar equal sign, the y bar here is 69, and minus we have beta 1. Yeah, we found out beta 1, and this should be multiplied into x bar. This is x bar. So the 39. So look, dear students, we just computed. So here the beta 1 is 5, and the intercept, which is beta naught, that is 39, and we just found out these values. So now you can simply write this regression like y, which is y hat, is equal to, you can say that is 39, right, and plus, and we have 5x. Okay, the most important thing, dear student, here is the interpretation. What is the interpretation? You can say a unit change. This is the coefficient. The 5 is coefficient of x, which is also slope. You call it slope, where this slope of the line is determined by this beta 1. So you can say a unit change in x is leading to 5 unit change in y. So the interpretation is simply a unit change in x is leading to 5 units change in y, dear student. Okay, you have learned the basic concept and idea of regression, dear students, and hopefully the idea is clear. In this regression analysis, first you should learn that you must have two variables, and you should specify which one is dependent, which one is independent. Usually the x, this is used for independent variables, and y is dependent variables. This is also called explanatory variables, right? Independent, also sometimes it's called regressor. And y is dependent variables. Then if you just do it manually, so you should do all these steps, right? But also you can just find out the regression line using this method I have just shown you how to just find out the regression line. And also we have some other fast way of finding out the relationship, inshallah. I'm just explaining it. Okay, dear students, if you just try to find out the output of regressions, we have one other method here in Excel. Okay, just these are two variables. Simply in data, click on the data analysis, and here we have regression. And the regression, we have x, which is the y range. Simply this is our y value. Just take the y value here, and then we have x, this is our x, right? Simply, and then okay, just select the labels because we are using xy labels. Confidence interval, if you are interested in hypothesis testing, why we have the alpha of 0.05, right, less than 5%, so the confidence interval should be 95%, and the output range is, assume it's here simply. Okay, so this is, dear students, the result of regression. Now what is the explanation here? Okay, in this regression function, dear students, we have 5x. The 5 here is the coefficient of x. You can say slope, right? Or beta 1. So beta 1 here is, this is the beta 1 simply, right? And then 39, this is intercept. So this is intercept. Okay, dear students, in this output, one more information I just try to give the explanation of. Okay, I just bring changes in these values. Why now it's just simply dynamic. But for if you just bring changes, you have to run this regression again. Why? Because it's not dynamic, it's not functional formula. Okay, so this one is dynamic. Okay, for example, if I'm changing this is 2 and this is 50 and 4, I just make it 70, right? And then here we have 65, I just make it 60, and then here we have 80, and this I just make it 83. Okay, dear students, so look into this line. Now we have more variance here. Previously, the faded line, it was representing the more variations, right? More of these points, they were closer. Now these points are somehow they are not closer. I just can even make changes, make it 73, right? And just make this value 83. Okay, dear students, keep in mind if we draw the average line here, this is suppose the average. Okay, sorry, I'm just drawing actually. Okay, dear students, this point, this one, this point, which is here, this one, closer to, just wasted my time. Okay, for example, dear students, here, if this is this value, we call it y actual. This is y actual, right? And the line which is predicted here, this is the point which is predicted. This is, we call it y hat. This is y hat. Simply, in the point which is here, right? Which is here, it's been this point, which is exactly in this line, this point. This line, dear student, is y bar. Okay. Okay, now dear student, look here. So you can say this is the total area from this point. This is the total area. This is the total area which is explained, right? This is the total area variations, you can say, right? For value of this x, the total variation is here, right? And the difference of y1 and y hat, this area, this from the y1 into y hat, this area, these students, this is just shown by, we can say, sum of square errors. We call it sum of square errors, simply sum of square error, and this equal to, you should just take the summation and start with x, sorry, y actual minus y hat. This is y hat. Okay, okay, this area from y actual, you should minus y hat, this area. Okay, this is called sum of square error. And what is sum of square regression? So you can say from y hat, when you minus this central value, actually this area, right? So you can see it's called sum of square regression, sum of square regression, sum of square regression. Okay, I don't have digital pen, I'm sorry for this. So you can say sum of, okay, okay, from y hat, when you minus y bar, okay, this is simply the total variation. Why? Because variation is just around the central value. And what is the total variation? Simply the total variation, we call it TSS, total sum of square, and this equal to, it's mean from this y actual, you should subtract the y bar. So you can say sum of y, this is sum of y, okay, here, y actual, right, minus simply y bar. This is total sum of square, dear students. Okay, so you can say this is explained area, right? This is explained area simply, and this is unexplained area, right? This is unexplained area, and this is the total area or total variation, dear students. Okay, so in Excel, dear students, here we have the R square, which is also called coefficient of determinations. So when you divide the sum of square regression over the total square, so that is just giving you the value of R, right? R square simply, and this is equal to the sum of square, simply sum of square regression is R, which is sum of square regression, or you can say this is explained area, should be divided by TS is a total sum of square. So the answer which is directly computed here, that is 0.98, dear students. Okay, so what does this mean? It's mean 0.98 or 80 98%. Okay, this is the explain area, right? So it's mean in total variations, which is from the x bar up to the y actual, this is the area, this is the area, simply this is the area which is explained by the predicted line and regression line, dear students. So that is why the explained area, when is divided by the total variations, the explained variation is divided by total variation. This is just giving you the percentage of the variation explained by this line. So this is actually just explaining how fitted the line is. When this explanation is with the variation here is high, this value is actually between 0 and 1. So if it is getting closer to 1, it's mean the regression line is explaining more variation, and if it is getting closer to 0, it's mean the regression line is explaining less variation here, students. Okay, so in this lecture you have learned the basic idea and concept of regression, and also you have learned the coefficient of determination, which is r squared, dear students. In next session, inshallah, we have some other topics related to regression model, and we will cover them there, inshallah. And the hypothesis testing, which is related to the regression analysis, I have not explained, but very much simply, I'm just giving you a touch that how to test hypothesis when you are using regression analysis, dear student. For example, if I have hypothesis, I just develop hypothesis. In this example, I say the null hypothesis is the advertising budget does not affect sale, for example. In my H1 hypothesis, we say the advertising budget is positively affecting the sale. Okay. Now, for this, I have chosen the 95% confidence interval, if you remember, right? If you just update this graph here, right? Because in, we brought some changes here, data, and just click on data analysis, and we have regression. Just everything is okay, but here I just 95%. It means the significance level I am interested in is 5%, alpha 5%. Okay, and the output range is the same. You just click OK. Now just press OK, dear students. Okay, look, now the r square is less. Why? Because I just changed the values, right? And here the x is 4.85, right? And the intercept is 43.5, dear students. Now, for 95% confidence interval, okay, I just remove back, okay, which is h naught. What is the null hypothesis? The you can say advertising budget does not affect sale, right? And what is H1? I say advertising budget is positively affecting sale, right? Like this. This is my claim. So now here, if I have chosen 95% confidence interval, then the p-value should be less than 0.05, and here the p-value is not less than 0.05. So in these situations, I cannot reject the null hypothesis. Why? Because if you're interested in 95% confidence interval, it means the alpha 5%, so the p-value is not less than 0.05. That's why I cannot reject the null hypothesis. So I can simply say, yes, there is variation, 73% variation explained by this line, right? And a unit change in x is leading to 4.85 unit change in y, but this relationship is not significant under alpha 5%, dear students. Yes, you can say it's significant under alpha of 10%, dear students.